Welcome back, guys. Hope you are doing well. So, we are going to continue the series of glossaries. We are on part 3 of letter C. So, let's start. First one is continental drift, the movement of the continents around the Earth's surface. So, let me just take you to the illustration so that you can understand it better. So, 200 million years ago, there is only one continent, which is Pangaea. Pangaea. The given current, estimated drift rate and direction of the plates, we can trace it their movements back into the past. About 200 million years ago, they would have been at approximate position as shown. The continent current position are as shown in the D figure. So today, in today present world, we are in the condition where all the continents are in this configuration as suggested in figure D. So due to this, through this you can understand that India, where I live, is not a part of Asia, is a part of Africa. It just broke down from there and reaches to the Asia and strikes Asia, which leads to the formation of Himalayas. Himalayas are very important as they are both technologically and democratically very sustainable for the India, and hence making it very unique figure throughout the world. Next is continuous spectra. Spectra in which the radiation is distributed over all frequencies, not just a specific frequency range. A primary example in the black body radiation emitted by a hot dense body. Let me just take you to the electromagnetic radiations. So here you can see that there's a radiation coming out. Radiation, so there are three types of spectra that are possible in nature, which are emission spectra, continuous spectra, and absorption spectra. All of these spectra have their different properties and their different functions in nature. But right now we will discuss about continuous spectra. So in continuous spectra, you are going to receive a continuous radiation throughout. Hence all the colors, all the radiation are present in the following. In emission spectra, there are only specific wavelengths of light which are present, and all other will be black. You can understand that on a black background we have specific wavelengths of a particular gas cloud, or it can be anything. Okay, it could be anything, but it should be hot and should emit light. Here we have used hot bulb, which is convectionally radiating the energy to the gas cloud, hence giving it some energy to radiate different wavelengths of light. And third one is absorption spectra, in which you can just say that in continuous spectra there are black lines which indicate that following spectra have been absorbed, following wavelengths have been absorbed by a particular substance. Okay, let's move on. Next is convection. Convection, cunning motion resulting from the constant upheaving of warm fluid and concurrent downward flow of a cooler material to take its place. Let me just take you to the figure. So here we, okay, sorry for that, just give me a second. Okay, it should be in astronomical illustrations. This is the figure which I have taken. Yes, so here you can see the hot air, the warm air is moving up and the cold air is going down. This is the resultant. This is the convention. So do you know how winds are generated on earth? The winds are generated on earth due to sun. How sun? Sun emits radiation which makes the air warm in the atmosphere, hence creating a convectional current which leads to the movement of warm air from equator to the poles where cold air is present. Hence a current is established which lead to the formation of wind. Okay, interesting. Yes. Next is convectional cell that we have just discussed, circuiting region of up yielding hot fluid and sinking cold fluid in conventional motion. This is called conventional cell, the region where this following is happening. Conventional zone, this is also the region where the following is happening. Region of the sun's interior, oh sorry for that. This is the region of the sun's interior lying just below the surface, where the material of the sun is in contact conversion motion. This region extends into the solar interior to a depth around 20,000 kilometers. Let me just take you to the illustration. So this is the illustration that I'm talking about. Yes, this one. So here you can find out different layers of a star, different layer of particularly talking about a sun. So there's core, then radiation zone, then convectional zone where it's talking about, and it goes down to 20,000. Okay, it's 22 lakh. It's 2 lakh kilometers. It goes down to 2 lakh kilometers. Okay, and okay, this is the corona region of the sun. Okay, you can take the PDF from the description and can read it yourself as well. Okay, I'll provide it to you. Okay, let's go. Next is convectional zone. We are thorough with this. Now co-orbiting satellites. What are co-orbiting satellites? The satellites which share a parked orbit, which share same orbital. So do you know that if you want to establish a satellite in the around the earth, you have to take permission from all the space agencies throughout the world, because it states that you are just parking that place, you are just owning that particular region, you are owning that particular orbit. Hence it is a very controversial and very delicate work to do. You cannot just take a rocket and send your satellite. You have to do a lot of diplomatic work also. So this is how co-orbiting satellites work. They share a same orbit around a planet. Next is cooperation principle. So before the period of great Galileo, it was understood that, or it was stated that earth is in the middle of universe and all of the other celestial bodies move around the earth. But after the theory of corpusculus, he stated that the earth is not at the center but is orbiting around sun just like other celestial bodies that they are able to observe. Hence a geocentric universe have been declined by corpusculus, and a solar centric, a sun centric universe is established. Okay, a thesis of sun centric solar centric universe is established. In his way to achieve this, he have to face a lot of criticism and a lot of pain he has to suffer. But after his death, Galileo took his stand and just make this thing validated that earth is not in the middle but just like other planets revolve around the sun in elliptical orbit. This is stated by Kepler in the upcoming years. Next is Kepler revolution, the revolution that earth is not the center of the universe. Okay, you can take a look at the detailed papers that Corpus describe in his thesis in the book On the Shoulder of Giants by Stephen Hawking. We are just going to start a new series, a book review, where I'll review many books related to astronomy so that you could get a much broader idea about what to study and how to study and how to approach problems in astronomy and how the great scientists do it themselves. Okay, so keep supporting me just. Next is core. Core, the central region of the earth surrounded by mantle, and the central region of any planet or star, as we have discussed in the illustrations in just some minutes ago. So you can just refer to that image also. Okay, next is core acceleration theory. theory that the Jovian planets formed when icy photoplanetary cores become massive enough to capture gas directly from their solar nebula, see gravitational instability theory. So the following theory is a subpart, is a subset of the theory which suggests that due to the increase in gravity of the growing fragments, they are able to attract more and more gases toward themselves and forming more and more massive structures. And the density goes on decreasing in their core, hence a spherical structure is formed, which we know today are planets, planets, galaxies, and all the things that we can observe in our universe. Next is co-collapse supernova. See supernova second. We have discussed earlier about supernova 1 and 2. Supernova second, let me just remind you, that is supernova whose intensity of radiation decreases slowly with time. And due to core collapse, this is just a general cycle of a star formation and death, and this is a collapse expansion. This continuous cycle goes till the star go dead. Okay, supernova is just a star, but supernova is a star which is very massive, and due to its explosion, if it just collapse and gets exploded away, it could cause a massive destruction. Next is core hydrogen burning. The energy burning stage for main sequence stars, in which helium is produced by hydrogen fusion in the central region. A typical star spends up to 90% of its lifetime in hydrostatic equilibrium, brought about the balancing between gravity and the energy generated by the core hydrogen burning. Let me just take you to the illustration so that you could understand this. So this is how the cycle in a typical star works. So there are two pressures or two forces which are acting on the surface and on the star in itself. So first one is pressure out due to the gases which want to expand, and second is gravity in, which wants everything to be dense and to be hold tightly. Okay, these two forces just in 90% of the lifetime, a star is in hydrostatic equilibrium, which means that the pressure out and gravity in both balances each other, and in 10% it is the unstable state. You can say it is an unstable state where there are so many destructions, expansion, collapse going on the sun or any star. Okay, so these are the two basic forces which act in the star. So you can see that first the star is in normal size. In the second image it just collapses down, and in the third image it expands. And you can also refer to their colors, that it is bright yellow, then it is dull yellow, and it's very bright yellow. This also signifies that the intensity of radiation has increased significantly in ongoing expansion. Hence intensity is directly proportional to surface area of the sun. And in the middle, the core, there is a constant nuclear fission, nuclear reactions going on there, in which two hydrogen atoms come together and form a helium atom. When they are done with the hydrogen, they start fusing helium together to form carbon, and so on till iron is formed, because iron is the most stable form which can exist in the universe. Okay, iron forms the core of each and everything, each and every star, okay, each and every star. Next is cornea. Cornea, a part of eye, the curved transparent layer covering the front part of eye. It is called cornea. I just want to mention here something about astronomy, that astronomy don't restrict itself to a specific topic. It takes all the concepts and subjects under its roof. You cannot imagine astronomy without biology, without chemistry, or without even a smallest thing yet that you can just miss out. This is a collective theory. Astronomy is a collective science which goes hand in hand with each and every concept, or each or every knowledge that we know about anything. Okay, because in the universe there is no limit that how this could be possible, how that can be possible. There can be various theories, various concepts, but you have to know that on the smallest scale or in the biggest scale there are very similarities, but at the same time very differences as well. Okay, so astronomy is very fascinating and you should join astronomy. And if you have any question regarding any concept or want me to make some special videos, so you can just comment down below in the comment section and I'll definitely approach to you. Okay, so this is cornea, the biology part. Okay, biology part. And okay, next is corona. As we have discussed earlier in the okay, corona, yes, just take you to the illustrations. Corona. Oh, where's corona? Okay, I'm not finding that corona, I'm not getting that. So let us skip for this time. Okay, don't worry. Yes, we can discuss about the sun corona. We have discussed this earlier as well. Okay, sun corona, we are very much familiar with this, but about venus corona we must have to look this. Okay, I'll just take you to that page. Coronal center, coronal injection. So let's have a detailed explanation about corona. Just wait a while. So let us discuss in detail what is corona for sun. We are going to cover each and every terminology related to corona. Okay. So first one is solar flames. Solar flames are the phenomena which arises due to this. Okay, these are coronal holes. So corona is basically, as we have discussed earlier, is the layer. Corona is the outermost layer of the sun which is bright and has a high temperature. So what are coronal holes? You can see there is a pattern going on in these images. These are images of sun taken at regular intervals after some time. These frames were taken at roughly 2 days intervals, straight standing at the left. Okay, so you can see that this black area is shifting and moving in the right direction with each interval of 2 days. What is this? This black portion, this black region is coronal hole. A image of X-ray emission from the sun observed by the satellite. Note the dark V, the cloudy V, cornel hole traveling from left to right, where the X-ray observation outline in dramatic detail the abnormally the thin regions through which the high speed solar wind streams forth. Okay, so this is the image taken in X-ray spectrum. They taken in X-ray spectrum, so these are not visible to our normal naked eyes. Hence we do not observe this phenomena or this black haze on the sun with our eyes. So this is taken in X-ray spectrum, X-ray wavelength. Okay, B image, this one where the charged particle field lines loop back to the sun. Particles are trapped around due to the magnetic field around the sun. So B, charged particles follow magnetic field lines that compete with gravity. Means that particles want to escape from the sun, but gravity want to keep them tight together. When the field is trapped and the loop back towards photosphere, the particles are also trapped, otherwise they escape as a part of solar wind. Let me just take you to what is solar wind, what are solar flame. So solar wind is a very destructive event which occur continuously on various stars, and particularly for our sun they are very frequent, and millions and trillions of neutrinos passes through the earth each second due to this solar burst. These are just like winds which are flowing in the space, flowing in the solar system. and you can analog it with the winds of blowing in the sea, blowing in the sea area. Okay, but this is the space, this is the outer black universe space where solar flames arise. So these are the regions where magnetic field are strong, hence making two poles, north and south, and the two poles make the way for the charged particle to flow between them, hence causing a very violent actions which result in finally the solar winds in the atmosphere. Okay, so solar flames are much more violent than the prominence. A solar flame is an explosion on the sun's surface that sweeps across an active region in matter of minutes. Okay, this process takes just matter of minutes and thus just gets instantly with the click. Okay, just like Thanos do. Okay, you guys know about this. Okay, accelerating solar material to high speed and blasting it into the space. Okay, the solar particles are given very high velocity, hence they are very destructive. Okay, so these solar winds and the charged particle are responsible for the phenomena of aurora on different planets, not only on earth but on various planets in a solar system. Okay, oh, let's see, we have other images for solar flame. Yes, we have coronal mass ejection, that the solar flames, this is the solar flames. This through the solar wave, not only the radiation but a lot of matter also ejected out. This is the, you can just take a look at this is the magnetic field which are formed by the charged particle which have been ejected by the sun, and it is coming towards the earth, it strikes the earth and hence destructs the magnetic field or interferes with the magnetic field of earth. Okay, so here magnetic field strikes coronal mass injection. In the second image, red region depict high energy charged particles, red region, and the charged particle enters earth's magnetosphere. Okay, magnetosphere depends upon the is arise due to the molten core of earth and is responsible and for the protection of earth from these harmful particles, because these particles are trapped within the magnetosphere and only few of them are able to reach to the earth directly. Okay, coronal mass injection, let us discuss this in detail. A few times per week, on average, a giant magnetized bubble of solar material detaches itself from the sun and rapidly escapes into the space. As shown in the Soho image taken in 2002. Wow, 2002. 1 year older than me. Okay, my birth year is 2003. Okay, so these circles are artifacts of an imaginary system designed to block out the light from the sun itself and encouraging faith features of a larger radii. Okay, so you can see this is a very large radii which is constituent our main aim in this image is to see how the heat or how the hot matter is being ejected. So this is a thermal image which show that very high energy particles are being ejected and are represented by very bright colors. Okay, B, should such a coronal mass injection, this one, should such a coronal mass ejection encounter Earth with the magnetic field oriented opposite to the our own as illustrated, the field can join together as in the parts. So in part C, allowing high energy particle to enter and possibly severely disrupt our planetary magnetic field, means they interfere with our magnetosphere. By contrast, if the field are in the same direction, the coronal mass injection can slide by the earth and with little effect. Okay, so here they discuss that if the direction of magnetic field is same as that of the direction of the magnetosphere, the field, the earth's magnetic field, then it will be easier to get rid of the following flames because they are going to slide out, but if they have opposite magnetic field they are going to cancel each other, hence having a greater impact on each other. Okay, so let's see, are we left with something else? Oh, yes, we are talking about Venus corona. Okay, Venus corona. We have discussed about the sun's corona. Let's talk about Venus corona that we have just lifted. This corona Aine, called Aine, lies in the plain south of Amphiodine Terra, and is about 300 kilometer across. Okay, note the pancake shaped lava domes at the top, the many fractures in the crust around the corona, and the large impact craters with their surrounding white roughed ejecta brackets that stunned the region. Okay, this image is given by NASA. So this is the corona. This is the corona. These are the lava domes. So this matter might have been ejected by the volcanoes, and there are so many craters and lines, very rough surface. Okay, this is a very rough surface for Venus, hence this is the corona. Okay, with this whole figure in which two these big structures and a crater is contained is called a corona. Okay, it is 500 kilometers radius. It has a 500-kilometer radius. Okay, fractures, lava domes, etc. Okay, let's see, do we have something more? No, we are done with corona. Okay, so let's continue our series. Okay, so we are done with corona hole, vast region of sun's atmosphere where the density of matter is about 1/10 lower than the average. The gas these streams freely into the space at high speeds, escaping the sun completely. Okay, very good. Coronal mass injection, giant magnetic bubble of ionized gas that separate from the rest of the solar atmosphere and escape into the interplanetary space. Okay, next is corpuscular theory, early particle theory of light. So in the early time, in the time of Newton, in the time of Galileo, it is very much a prominent question that what is light? Is it a particle or is it a wave? But today the conclusion have been drawn that light is an electromagnetic wave. Okay, light is an electromagnetic wave and is made up of various radiation, ultraviolet radiation, uh, UV radiation, visible radiation. Okay, we are going to talk about radiation. So this is the image in which we are going to talk about radiation. So wavelength, this is high wavelength, and we have discussed in the previous video relation between wavelength, velocity and frequency of a wave. Okay, so these are some electromagnetic, this is the electromagnetic spectra which contain gamma rays, which are the most energetic, having the highest frequency, then x-rays, ultraviolet rays, visible region in which the light which we see is present in visible region, then infrared light are responsible for the heating effect. The clothes we spread out in the sun are dried because of the infrared rays. Okay, this next is FM radio. So these are the radio transmission, and you can just treat it as the communication we are able to establish with each other. That you are watching this video on YouTube, this is because of the FM radio waves, FM AM radio waves. Okay, and in between the infrared and the radio wave there is a microwave oven works on these microwaves. Okay, so we are going to discuss how these basic machinery works, that how microwave heat the food products, how we are only be able to see visible light, why not x-rays or any other, in the upcoming video. So stay tuned to my channel. Okay, there's a lot more coming to way. So let's continue. Yes, next is cosmic density parameters. cosmic density. So this is cosmic, okay. Now let us discuss about what is cosmos, what is cosmic, and what they mean by this. So let me just take you the basic terminologies. What is a cosmic density parameter? Ratio of the universe actual density to the critical density value correspond to zero curvature. We have discussed this earlier in predicting the future of universe, okay, in the second part of SIAC thing. Next is a cosmic distance scale, collecting of indirect distance measurement techniques that astronomers use to measure distance in the universe. So there are various techniques through which astronomers measure distance. Some of them are discussed here. So the most basic is radio wave transmission. Second is the triangulation law, and going up and up our scale of distance increases, and we are going to discuss each and every topic in detail in the coming videos, okay, don't worry. So you can just memorize this also. So this is the pictorial or graphical representation. How do we work with the distances in bigger scale? How do we get to the conclusion that we just got the correct distance of the particular galaxy from us, okay. Next is cosmic evolution, the collection of several major phases of the history of universe, namely particulate, galactic, stellar, planetary, chemical, biology, and cultural evolution. Okay, let us see. So this is the arrow of time, how this all started and how this all going to end, okay. This is the present time which we are inherited. So the arrow of time, some highlights of the cosmic history as it relates to the emerge of life on earth are noted along this arrow of time from the beginning of the universe to the present. At the bottom of the arrow are seven windows outlining the major phases of the cosmic evolution. Evolution of primal energy into elemental particles. Wow. Primal energy into elemental particles of atom into galactic and stars, of stars into heavy elements, of elements into solid rock planets, of these elements into molecular building blocks of life, of those molecules into life itself, and advanced life form into intelligent culture and technical civilization. So much fascinated, so much knowledge in these just few lines. You can just take astronomy in these lines, okay. Astronomy is confined to these lines, but the questions that why, how, this makes astronomy a fundamental science to study and a most fascinating science to study, okay. Let's move on. Okay, next is cosmic background, okay. Let us just make the definition. Cosmic microwave background, the almost perfectly isotonic radio signal that the electromagnetic remand of the Big Bang. So this is an imprint of the Big Bang. This is an evidence of the Big Bang. Let me just take you to the cosmic background. Wow. So this is the cosmic background. Early structure, interactive. The entire microwave sky as seen by Planck spacecraft, the instant, shows a compatible high resolution map of a small patch of sky obtained by the ground based cosmic background image instrument at 30 gigahertz 1 centimeter wavelength. The bright blobs are slightly dense than the average region of the universe at the age of roughly 4 lakh years or 4 million years. They will eventually contract to form a cluster of galaxies. So they are bright regions. These are more dense than the region around this, okay. This is the temperature graph. You can see the temperature also. The bright region are much more hot, okay. So these are radio waves, microwave background. So let us meet the scientist who discover the microwave background and give the evidence in favor of Big Bang. So these are the two scientists, microwave background discoverers. Okay, these are the two scientists, and you can see a radio telescope behind them, and this is responsible for collecting so much data and making of the microwave background that we know today. The sugar scoop antenna, wow, was built to communicate with Earth orbiting satellite, but was used by Wilson Wright, and Arya Pangias to discover the 2.7 Kelvin cosmic background radiation. Okay, so there is a very interesting story about their discovery. When they just established their telescope, its main motto was to communicate with the Earth orbiting satellite, but in at each and every time when they just stood back and make the observation, they find out a disturbance coming their way all the time. So they try to remove the nest of the pigeons, which they thought could be the reason for this unwanted noises, but that was still there after the removal of each and every obstruction. So hence they get to the conclusion that these are the microwaves which are there for the evidence of Big Bang. Hence, this is an accidental discovery, but one of the greatest discovery for the mankind. Okay. Wow. Do we have something else? No, we are done with the images, and it's just a small fraction we are left with now. Redshift, cosmic redshift, the component of the redshift of an object that is due to only the Hubble flow of the universe. So Hubble flow means going away. Okay, going away flow. Cosmic principles, two assumptions that make up the basis of cosmology, name that universe is homogeneous and isotopic on sufficiently large scale. These are called the cosmological principles, and these are the two assumptions of which made up the basis of cosmology. What is cosmology? The study of structure and evolution of the entire universe is called cosmology. What is cosmos? Cosmos is the universe. Crowd focus. Focus produced far from telescope using a series of mirror, allowing the use of heavy and fine-tuned equipment to analyze the image. Okay. Next is crater. Bowl-shaped depression on the surface of a planet or moon resulting from the collision with the interplanetary debris. So this is the image of moon, in which you can see there is a very much holy, very much depressed. This is due to the collision of various astronomical debris on its surface, which led to the formation of craters. So craters are basically the depression caused by the collision of debris with the surface. Okay. Next is crescent. Crescent. Appearance of moon or planet when less than half of the body's hemisphere is visible from the earth. So crescent is a condition in which only half of the body, half of the planet or half of the object is visible to us all the time. So do you guys know that from the beginning we have just seen only one face of the universe, one face of the moon, one face of the moon. There is a other face is always in dark, other phase is always in dark. This is due to the reason that the time period for revolution and time period for rotation on its axis and revolution around the earth is same, that is 27.3 days precise. Okay, so this cancel out the effective effect, the resultant effect, and we are just able to see one face of the moon at all times we observe it. Okay, we are going to discuss this by illustrations in the coming future. Okay, when we are going to study in detail about moon, so stay tuned. Next is creased maximum departure of a wave above its undisturbed state. Crust. So when a wave is taken into account, there are two properties, or there are two characteristics, which are crust and trough. These are the amplitude of the wave. Okay, so this is just depicted by the following sentence: the crust. Okay, this is what is critical density: the cosmic density corresponding to the dividing line between a universe that collapse and that expands forever. Okay, we have discussed it earlier so many times. Next is critical universe, the universe in which the density of the matter is exactly half of the density, so critical density, the is exactly equal to the critical density. The universe is infinite in extent and has zero curvature. The expansion will continue forever until will approach an expansion speed of zero. That means when will the acceleration of expansion will stop? We are in the state of collapsing, that nothing is going to stay, everything is dynamic in this universe. Crust, layer of earth that contains the solid continents and sea floors. Okay, no explanation for this. What is C type asteroid? Which contain carbonious asteroids are C type asteroid. Next is cultural evolution, change in the idea and behavior of a society over time. We are culturally evolving. Okay, we are culturally evolving at every place, at every time. In adolescence, our body grows to a greatest extent. But after that, our body is not in evolution, but our emotions, our culture, our intelligence is always in dynamic growth with time. Okay, the last definition for the sea, oh, it's in, of course, it's been a so long series. So what is current sheet? Flat sheet on the Jupiter's magnetic equator, where most of the charged particle in the magnetosphere lie due to the planet's rapid rotation. Okay, sheet of the Jupiter magnetic equator, where most of the charged particle lies in the magnetosphere. This is the current sheet where charged particle lies on Jupiter. Okay, so these are the glossaries we are left with. Don't worry, we are going to cover it easily, and this has been very interesting. Although there's so much work to do, but it is most interesting and the most fascinating for me. So in the upcoming videos, I see myself describing you my new read. This is the programming of the universe. I'm currently working on this and I have covered a lot. About 50% of the book have been covered by me. After I'll cover this book myself, I'm going to post videos related to this. This is an excellent book which makes computer programming and the universe correlate with each other, hence making the understanding of the universe to an another level, with another eye or with an another angle. You can explore this, so stay tuned, a lot coming your way. Okay, so signing off. Bye bye, keep learning and keep exploring. Okay.